Hi friends, this is Hari Babu, Department of EEE, JNTUK College. The subject I am going to deal is Network Analysis, Unit 1, Introduction to the Electrical Circuit. The syllabus covered in this unit already discussed, and the topic basic definitions and network allocations are discussed in the previous videos. Okay, so coming to the in this video, the energy sources, the topic 3, energy sources, right? So the energy sources are classified into two types, mainly two types. So first one is independent sources, second one is dependent sources. Okay, so independent sources, the name itself, it has independent sources. Okay, so independent, it has two types. First one is a voltage source and second one is current source, right? So voltage source, again we have classified into ideal voltage source and practical voltage source, but regularly we use actually practical voltage source, but we have to define ideal voltage source also. Similarly in the current source also we have ideal current source and practical current source, right? So coming to the first two topic, voltage sources, there are two types, ideal voltage source and a practical voltage source. First one is ideal voltage source. The definition of ideal voltage source is a voltage source is a two-terminal device whose voltage at any instant of time is constant and it is independent of the current drawing from it. Nothing but a simple diagram I have drawn here. This is a circuit, nothing but an ideal voltage source representation. The representation of ideal voltage source. Okay, it has no internal resistance. The internal resistance I have not mentioned here. The internal resistance of this voltage source is 0. The ideal voltage source have 0 internal resistance. Okay, so here also I mentioned the ideal voltage source representation which has internal resistance is 0. Okay, so as the current increases, okay, now the value of current increases, but the voltage across the terminals is always constant because there is no voltage drop occurs in the circuit because there is no resistance. So there is no resistance and there is no voltage drop across in the circuit, so that's why the voltage terminals voltage is always constant as the current increases. Okay, as the current increases the terminal voltage is constant, right? But in case of practical voltage source it is not possible because it has some internal resistance. Sources having some amount of internal resistance is nothing but a practical voltage source. Okay, here I representation for practical voltage is this one. So it has some internal resistance, that is R. Okay, the internal resistance of voltage source, the representation of practical voltage source, very important. The voltage source in which the resistance is connected in series, but it is not at all a practical parallel. Okay, so this is a practical voltage source. So the practical voltage source representation is always the voltage source in series with resistance only. Okay, right. Coming to the characteristics, here I mentioned the current passes through the as increases the voltage drop take place, that is the characteristics are drawn reduces actually, because as the current increases the voltage drop occurs in the resistance, across the resistance the voltage drop across the resistance is occur, because according to Ohm's laws that is V equal to IR, right? So we, as the current increases the voltage drop across the resistance also increases because the terminal voltage is reduces. Okay, previous cases the voltage across this one is always and this one because there is no drop, but in this case the voltage applied voltage is V, but some voltage drop take place, the terminal voltage becomes reduces because as the current increases, the voltage drop across the resistance increases, so the terminal voltage becomes reduces. That's why the characteristics are reducing characteristics. Okay, the due to the internal resistance voltage drop take place. Okay, voltage drop take place here in the resistance. Okay, and it causes the terminal voltage to reduce. Okay, the terminal voltage becomes reduced. Okay, this is about voltage source. Okay, representation of voltage source always mentioned, this is has internal resistance is 0, but in case of practical voltage source representation is an ideal voltage source in series with resistance, an ideal voltage source in series with resistance. Okay, it is not at all a parallel. Okay, right. Coming to the current source, so first one is ideal current source. So the ideal current source is a source where the current is constant for any load as the voltage varies. Same in case of voltage source also, but different is old current source here. So the representation of current source is like this. Okay, the characteristics drawn here. As the voltage increases, okay, as the voltage or time increases, the current always is constant. The current always constant, right? Coming to the practical current source. So the practical current source is represented here. I mentioned the representation of practical current source. The practical current source is represented with an ideal current source in parallel with resistance. Very very important. But in case of voltage source, in series with resistance. But in case of current source, the current source in parallel with resistance. Okay, so because of this resistance, some drop occurs, okay, across the terminals, right? So this is the drop across the terminals. This is drop. Okay, as the voltage increases, the current across the terminals becomes reduces because of this resistance. Because when the current passes through this way, okay, some current passes through this this resistance, remaining current passes through this terminals. Okay, so as the voltage increases, the drop across this resistance also increases. Okay, that's why. Okay, the drop, there is a voltage, there is a drop across the terminals because of this resistance. Okay, they change the current with changing of load resistance due to the internal resistance in it. Okay, right. Coming to the dependent sources, I have not mentioned in the classification. Here I classified dependent sources. There are 4 types of dependent sources. So first one is voltage control voltage source, current control voltage source, voltage control current source, current controlled current source. All the sources are dependent on other parameter. That's why it is called dependent sources, right? So the representations of dependent sources are like this. Here I mentioned here, plus minus means nothing. This is a voltage source. Here this is plus minus, let us say this is a voltage source. Here I mentioned the arrow, nothing but this is a current source. Here I mentioned arrow, this is a current source. In all the cases I mentioned, it is a diamond shape, that is a rhombus shape. Okay, either it may be, right? Okay, so here I mentioned V equal to B into VC, nothing but here V voltage source, B into VC, nothing but a VC, nothing but a voltage controlled voltage source. Okay, voltage controlled voltage source, this is voltage controlled voltage source. Coming to second representation is here V equal to nothing but a voltage source, R into IC, nothing but a current, right? Current controlled voltage source, current controlled, that is IC, current controlled voltage source. The second representation, current controlled voltage source. This is current source, right? But that is I equal to G into VC, nothing but a voltage, that is, so voltage controlled current source, voltage controlled current source, right? So the voltage controlled current source. The last one is I, that is but a arrow means nothing but a current source, that is I equal to, that is G into IC, nothing but a current, I nothing but a current controlled current source, that is current controlled current source, that is current controlled current source. So these are all dependent on other parameters, right? This voltage source depend on voltage, and this voltage source depend on current, and this current source depend on voltage, and this current source depend on current, right? So that's why these are called as dependent sources. Okay, thank you. Coming to the next two topic, resistance, we will discuss in the next video.